All right, on to a unit where we take the derivatives for a purpose. So here's the deal. I will be giving you the equation of a curve, and your job is going to be to find maximum and minimum values based on the fact that every maximum and every minimum, if you have a slope of the tangent, which that is a poor one of, every single one of them will have a slope of the tangent that is equal to 0. So your steps are going to be the same every single time. You're going to take the derivative, whether that means a straight derivative with derivative rules, or whether it's a power of a function, or the quotient rule, or the product rule. You're going to have to take the derivative and then set it equal to 0 and solve for x. Now, I will explain this stuff in a second after we've done that part, but please know that this leads us into word problems. So right now we're doing it for graphical reasons, but in the end, we optimize, we find maximums and minimum values so that we can apply this to situations in real life. In business, you want to minimize cost, you want to maximize your profit. In building materials, you want to minimize how much building material you have to buy. So those kinds of things. And we'll be taking a look at different types of word problems, and it all relates to a booklet. This stuff, I believe, let me just check. Yep, it's textbook material. So I'm going to erase this and dig out my tablet-y thing and start the question. And like I said, I will explain this business in a minute. So, all ready to go? Step 1. Take the derivative of the equation that is given to you. So in this particular case, I've given you f at x instead of y. So I'm going to use f prime at x. And if I take the derivative of 3, that's 0. I'm not going to write that down. And this is going to require power of a function rule. So drop the 2 onto the 2 and multiply. Keep writing. Make it a 1. Go inside this bracket and take the derivative of that, which is 1, and then clean it up. So we end up with 4 times 1, which is 4, multiplied by x plus 1 to the exponent 1, so I'm not going to write that down. So that's step 1, even though that took 2 lines. Step 2, because we're talking about maximum and minimum values, you're going to take the derivative 4 times x plus 1 and equal it to 0. Now there's a couple of ways you can approach this because it's linear, meaning it's not quadratic because it doesn't have a 2, or it's not cubic because it doesn't have an exponent 3. First thing I'm going to do, instead of multiplying the 4 through, is I'm going to divide both sides by 4 because it's relatively meaningless. And then we end up with x plus 1 is equal to 0, so we end up with x is equal to negative 1. So sometimes there's many values of x, sometimes there's one value of x. We are going to have to find the y value. So I'm going to do that over here. I'm going to pick a different color. Let's go for black. Remember that the y value is found using the original equation. So we are going back to this thing, which is in the question. And I'm going to put in negative 1 wherever there's an x. So there's an x, and this is pretty nice because negative 1 plus 1 is 0 squared is 0, and 2 times 0 is 0 plus 3. So we end up getting a point negative 1 comma 3. Now that's not the end of it, and it's not the end of it because of this. So this particular question says find the absolute maximum and minimum values for each function. And it gives you what's called an interval. So this means that you are not supposed to take a look at the whole picture. So the whole picture is actually a parabola. And if I were to have been kind, I would have given you the parabola in this order. So looking at this from a grade 11 standpoint, this is a parabola with vertex negative 1 comma 3. Oh my gosh, that must be our minimum or maximum. That's the vertex. it's stretched by 2, and then it does its business. The thing is, what this does is it says, please only look at x values from -3 to 2. So even though you have an entire parabola, this question is saying, can you only maybe look at this section? In which case you might have this as a minimum, and then you would have a maximum even though forever in both directions a parabola goes on. But because I'm only giving you a window, you have to test both this x value and this x value in the f at x. So I'm about to do that now. So now I'm doing the -3. And again, I'm putting the -3 in to the f at x to find y. And I'm putting it in wherever there's an x. So it's -2 squared. And -2 squared is 4. And 2 times 4 is 8. And 3 plus 8 is 11. So I also have that point. And then I have to test the other end value. So I have to test x equals 2 as well. And I have to test that in the original. So let's position it there. I'm telling you I'm putting in 2, and then I'm going to put in 2. There. And then I can pull off my bed mess. All right. So, maximum minimums are based solely on the y values. So we have to know how high or how low it goes compared to the x-axis. So if I look at this question, 21, 11, and 3 are our determining values. So this will be the minimum, and this will be the maximum. And we are done the question. This will be an absolute minimum or an absolute a local minimum or a local maximum. So yes, something happens there, but it's not as important as this one or this one. So let's take a look at another question. It'll be the same kind of thing. I'm going to bet that we end up with more than one x value, which means we have more than one test to do outside of the 2 that we have to do with the end values. So here's another one. Okay, so I'm happy with this one. And the reason I'm happy with this one is it doesn't give me the product or quotient rule or even the power of a function. I know it's a cubic, so that means it's an n shape, or in this case, a backwards n shape from advanced functions. Not that any of that matters. You just take the derivative and make it equal to 0. So I'm going to do this a little bit differently this time. Not too much different. Mostly because I don't have to clean this up. So I'm going to put a 0 here. And because I can, I'm going to factor out a -6x, leaving behind an x for -6x squared and a -1 for +6x. Then I'm going to dig out the green pen that some of you might still be annoyed by to show my work. And I end up with an x value of 0 and an x value of 1. Now, I'm going to have to test 0, I'm going to have to test 1, I'm going to have to test -2, and I'm going to have to test 2, and then I'll have to figure out where my highs and lows are, my maximums and minimums. Having said that, if I end up with values that are found from my work that are not between x is -2 and 2, you don't have to test them because it's outside of your window. So black pen to do my back to the original, so I can barely see it there. So f at 0 is equal to -2 times 0 cubed plus 3 times 0 squared is 0 plus 0, so that's 0. So I have a point 0, 0. on this curve. Next one. Hope I can fit this in. So 1 cubed is 1 times negative 2. 1 squared is 1 times 3. So I also have a 0.11. And it is a total coincidence that my input number and my output number are exactly the same. Next one. The one that's kind of forced upon us. So negative 2 cubed is negative 8 times negative 2 is 16. Negative, oh crap. Negative 2 squared is 4 times 3 is 12. So that ends up being 28. So see, I told you it was just a coincidence. And then this one, let's see if I can fit this in down here. F at 2, negative 2, bracket 2 cubed plus 3 times 2 squared. So remember, I'm always putting it back into this to find my y value. So 2 cubed is 8 times negative 2 is negative 16. 2 squared is 4 times 3 is 12. And I end up with negative 4. So in this case, I end up having an input of 2 and an output of negative 4. And now I can go looking for my max and mins. So out of negative 4, 28, 1, and 0, here is my maximum point. My maximum value is 28. My maximum point is negative 2, comma 28. So I know that that's the top of a hill, or the top of my window in this case. And here is a minimum because it's the lowest value. Negative 4 is lower than both of these two. So unfortunately, I did all this work to find out that these points weren't actually the max and mins in our window. All right, last question. So happy. Again, no product rule, no quotient rule, no chain rule. So why on earth would I be doing this question? Oh, could it be that I've got a cubed coming here? Yeah, that's probably it. And I don't have to clean this up. So 0 equals, I can common factor a 4x out of these, leaving behind x squared minus 3x minus 4, and that is factorable. So isn't it good that we did a lot of factoring in, I don't know, grade 10, grade 11, and advanced functions? Two numbers that multiply to be 4, that at the same time add or subtract to be 3. Green pen time. 4x is equal to 0. X minus 4 is equal to 0. X plus 1 is equal to 0. This is the tricky one. We end up with x equals 0. X equals 4. X equals negative 1. Okay, I'm a little upset by this because all three of my values are within my window. So that means I have to find x values for that. And I have that. So it's time to sub in each of these to f at x. I'm going to save myself a teeny bit of time for this one because I know if I put 0 in here, it's 0 minus 0 minus 0 minus 1. All right, so 4. Let's see if I can do some of this in my head. So 256 minus 256 minus 16 times 8 128 minus 1. So that ends up being negative 129. So 4 comma negative 129. Let's take a look at negative 1 now. Did that work here? Oh no. All that work for nothing. Oh, am I still going? I panicked. Whew. Gosh, I hope I'm not doing this for nothing. Negative 1 to the 4th, 1. Negative 1 to the 3 is negative 1 times negative 4 is positive 4. I'm sorry if I do quick math here and it's wrong. Negative 1 squared is 1 times negative 8 minus 1. So that ends up being this minus that is 0, so negative 4. Input, output. F at negative 2. Negative 2 to the 4th is 16. Minus 4 times negative 8 is plus 32. Minus 32 minus 1, so that's 15. I'm really hoping I get this right. And then finally, 625 minus 125 times 4, 500 minus 8 times 25 is 200 minus 1. So negative 75 minus 1, negative 76. All right, sorry for the chicken scratch. So I'm hoping that these are all my values. So this is top of a hill or bottom of a valley. Top of a hill, bottom of a valley. Top of a hill, bottom of a valley. This one is the end of my window. This one is the other side end of my window. So now what I have to do is I have to find the biggest number for y that I have in here, and that's going to dictate which one my maximum is. So that is this one. And I have to find littlest number. No!